Chemical sedimentary rocks. So the first animation is actually going to tell you how limestone is created, and that is actually formed from living organisms. And then in the second animation, it's about evaporites, which is how halite, common table salt, is actually created. Both of these are chemical sedimentary rocks, but they are formed differently. So please pay attention. This animation is going to show how limestone is formed. So limestone is formed from living organisms. So this is a brachiopod, and what we know is brachiopods live obviously in water and the seas, and it absorbs the minerals that are dissolved in the water. So in the water, we can't see them, but these dissolved minerals are there. So let's start watching. So this brachiopod shell is absorbing those minerals, and it's making that shell stronger and stronger and stronger. So like I said, that shell is made of calcite, and throughout its whole life, it's going to be absorbing those minerals. So unfortunately, the brachiopod dies, all right? So he's going to be joined by all the other brachiopods. So they're going to create layers. So let's see those layers form. So here's more brachiopods. So they're joined by others. They've created at least 2 layers in this image, this animation so far. So what happens next is that soft tissue actually is going to rot away. And all it's going to leave are these shells. So notice we've still got those 2 layers of these brachiopod shells that are made of calcite. They're really strong because they absorbed all those minerals throughout its life. All right, so now let's continue to watch. So now these brachiopods are getting buried deeper and deeper beneath these younger sediments, these younger brachiopod shells made of calcite. So here's what happens. We took the sand of calcite shells and it creates limestone. So if you look closely, we can actually see the small shells. All right. Coral reefs are very similar. They're made from living organisms that absorb those minerals. All right. This is a really close-up of algae and shells and snail shells. So this is what actually happens to them over time. The minerals glue them together as they are compressed by the pressure of the layers. These are really small living things that their shells helped make chemical sedimentary rocks. Notice how small these were. We couldn't really see these. Now, the chalk that we originally started to write with on chalkboards were made from shells and the calcite that made those shells really strong, those dissolved minerals that strengthened the microorganism's shell. So after, those shells piled up and it got stronger and they pressed together because of all those layers, just like with Earth, and the minerals made it strong, it actually created a sedimentary rock, a chemical sedimentary rock, chalk, which we're very familiar with. So sedimentary rocks you are very familiar with. You just didn't realize it. Evaporites are another type of chemical sedimentary rock. And this one's not formed from living organisms. So this is formed from groups of rocks that form from the evaporation of water. So remember, what's in the water? The dissolved minerals that we can't see. So let's watch this animation. The tide comes in, water flows from the sea into the lagoon, then the tide goes out. Most of the water in the lagoon flows back to the sea, but some of it stays behind, trapped by the sandbar. As the lagoon is very shallow and the sun is hot, all the water that was trapped in the lagoon evaporates before the tide comes in again. So here, let's do this animation. So we've zoomed in on this water. So what we know is as the water evaporates, it actually first creates gypsum. That's going to be the first evaporate that is formed. So that first chemical rock that's formed as the water evaporates. Then as it continues to evaporate, it's actually going to create halite, which is just common table salt, which we actually do put on our food. And then it's going to continue to evaporate, and that halite's going to get thicker and thicker and thicker. So those evaporates, those chemical rocks, are going to get thicker and thicker and thicker. So those crystals that we just saw kind of get bigger. Here is an image of a salt lake, Thar Desert in India. And so what happens is the water evaporates, leaving the halite and the gypsum left behind as that water evaporates. And as more water evaporates, that halite gets thicker and thicker and thicker. So in this next video is a model using salt, water, and a pan on your stove to show just a very quick animation or model of how evaporates are formed.
Imagine you took a tablespoon of salt and dissolved it in this small beaker of water. Then you added the water to a pan on the stove and cranked up the heat.
As time passed, in this case about 4 minutes speeded up, the water would gradually evaporate, and the salt concentration in the remaining liquid would get progressively higher until the salt began to precipitate out of solution.
You can see the salt crystals forming here and along the edges of the pan. Eventually, when all the water is gone, the pan will be coated with the same salt that was originally dissolved in the water.
Essentially the same thing happens in nature, just not as quickly. This occurs when water in isolated seas or lakes evaporates, leaving behind dissolved minerals.
For example, ancient Lake Bonneville covered much of Utah 10,000 years ago. Most of the lake dried up, leaving the flat lake bed covered in a layer of salt.
I hope after watching how limestone formed and the both animations and videos and models for evaporates helps you identify how both types of chemical sedimentary rocks are formed, because they are different. However, they all have to deal with those dissolved minerals in the water.